Hello, everyone. So what we are going to do now, because like I mentioned in the previous one, we have covered one of the stage of our data engineering journey, where we have seen how we can write the complex SQL statements that includes the Windows function, inner queries. We understand the joins. Before I shift towards the programming side of the data engineering, which is obviously needed, and we're gonna see how we can cover that aspect as well. I want to actually now bring the data visualization layer because unfortunately we have to present the data in a way that our business users can understand, or they can extract the maximum value out of it. So that's where the whole data modeling comes into the picture. We need to make sure our data models are robust and flexible for the changes which are happening at the source system, and also addressing continuously changing needs of the business. So that's where the data modeling play a very critical role in the data and analytics, because if your model keep changing and it's not very flexible to change, it might create a problem. And we have seen a lot of problems, system just go in halt state, or in failure state, just because of there's no way to update or to improve the structures that has been created in those tables, right? So we always need to make sure our designs are flexible, our models are flexible, so we can get the best out of our data model. So what we're going to do now, we're going to slowly now bring in the data modeling, as well as the analytics, which is obviously based on the history, and I'm going to actually discuss the historical and the operational models separately. But in this video, we're going to actually start with our data modeling for DEX language, because obviously, like I mentioned, now we need to move towards this step where we can present the information, and obviously we have all these professional presentation tool, including Power BI, Tableau, and ClickSense, that we can use to generate some really cool and powerful dashboard for our business. But obviously, these tools doesn't work automatically. We need to invest some energy. We need to build the backend layer for these tools, so they can extract the information from it and then it present to the user. So what I'm going to do, I'm not going to actually take a traditional track where we are going to discuss all those historical concepts. Let me just define the complexity by introducing three statements, that we are going to divide our tables into three major tables. One is independent table. The second one, we call them dependent table, and the third one we call them bridge table. So we'll later on, once we have mastery on it, then we add some more types in the modeling. But let's start our journey from these three types of table. So what are the independent table? So independent tables, they are denormalized. So we normally won't care about the normalization. We will combine the input from different table together, regardless whether the information is repeating or not. So that's normally not the concept in the independent table. Obviously, their main usage is to slicing and dicing the information. Once we have the aggregation and we want to actually split it, for example, we are getting the total cost and we want to see the breakdown of that product cost by product category or product subcategory. So independent tables are used to provide those dimension which actually slice that aggregation, and it will convert into a bridge table if it is depending upon an other table, right? So imagine we have one table which is an independent table, like it is not depending on any other table. But what happened, there is a table which is depending on this independent table. right? And now this table further depending upon another table, so then it will convert into a bridge table. We're going to discuss bridge in the separate one. Or it generally contain historical and non-historical data. Very important point you need to keep in your mind, that our independent table, they can have the historical data, or they cannot have the historical data, right? So for the historical information, for example, like I mentioned, we add the products over the time, so that will grow. And sometimes we just need to change the product information. So in the independent table, it's not like we are going to hit update and change the attribute. We are going to close the record and we are going to create a new entry. So it will create the history. So that's the historical information. Now for the non-historical information for independent table, for example, dates normally won't change. Like dates are the static concept, right? We create more date, but never ever happen like we go back and we change the day of the date. Like for example, yesterday on 29/07/22 it was Friday, but maybe after one month we're gonna say no, it was not Friday, it was Thursday, right? So it's never the case with the date. So hopefully you'll understand the independent table. Next one, dependent table. Like I mentioned, you can see from the name, once you design a model, find out that which table is the dependent table, right? And it's very easy. Let me give you a couple of hints, right? You're gonna see it's gonna have for example, it's gonna have the keys from other tables, right? So you can see as soon as a key enter into one table, so it's going to be in the parent-child or primary key foreign key relationship. This table will convert immediately into dependent table, because this record has a dependency on an other table which is independent from it, right? So for example, we are keeping the sale information of our warehouse. Now in this dependent table, maybe the key is coming from the product table, which is independent from this sale table, right? Because it can have some products or it cannot have some products, right? So products are completely independent. The same way, if you look at the product can sit there without have a dependency that they should exist within the sale table, right? We have many products which are sitting on shelf and people won't buy them, right? So you can now understand what's the concept of dependency and independency. The dependent table normally show the aggregation, like we normally extract the aggregate information. So for example, like I mentioned, if we are collecting the information in the dependent table, we might keep the sale information, like what's the price we have sold that product on, what's the product cost, what's the tax, what's the GST, all these sort of things, right? We will capture into our system that numerical value, because that value can further go and aggregate, right? So that value normally being used in the dependent table, right? Like I mentioned, mostly it contains the numerical data and it's surrounded by all the independent tables. Because why? Like I mentioned, with the product scenario, the keys are coming from the independent table, because they are the one who link with this dependent table, and they generate the useful information on our reports or dashboard. Or it's more the dependent table mostly contain the historical data. It normally contain all the sale history. We won't actually update or delete the data from this table. A dependent table generally contain all the historical. So for example, if we want to see the historical sale information, we're going to come to our dependent table and we're going to extract that information from the dependent table. All right. Next one. Oh, So I didn't actually mention in the bridge table into this slide because I think that that's enough for this video. I'm gonna keep it sweet, and why I'm actually keeping it till dependent and independent, because in the next video we're gonna discuss the data model which we are going to use based on the dependent and independent table for writing our decks as well as the SQL queries. So hopefully that will be beneficial and it will clarify the concept. And I'm gonna see you in the next video with the data model which we're gonna use. Thanks for watching.